Now it's time for our next talk, and Matúš Ferech will tell us about Nix, know what you are running, testing, and deploying. One thing I would mention before we start with the talk. This Python is a community event, and community is all about doing things bottom up. Nobody's really prohibiting you from doing things. You can do really cool stuff, and there's many communities in the open source world that are very active, do all kinds of in-person events. So, for example, the OpenStreetMap does mapping events. So if there's like a spot on the map that doesn't look too awesome, people do a trip. They book a cottage, they go there for a week, they collect data, upload it to the map. Very nice. It's something that that community will appreciate, where people get together face to face, make friends, and also do something meaningful. This is also true of Nix. There's hacking sessions where people rent a cottage and stay there for a week and just do coding, or there's a camp where they also rent out a place and they do these very informal events. And this is also kind of like a suggestion for you. If you are involved in anything, don't be worried to bring others on board, not just in the digital space, but actually face-to-face, in person, where we are living in a world that sometimes activity, civil society is being challenged, and it's really good to be mindful of that, and also to be active ourselves. So with that, I see that most of you have already sat down, so I think we can start. Matúš, the floor is yours.
Hello. Thank you for a nice introduction.
Microphone, prosím tě.
Okay, thanks for a nice introduction and thanks for having me. So I'm Matúš, and I'm a software engineer at Deutsche Telekom Cloud Services. I'm interested mainly in systems programming and distributed systems. Last year, I joined a program called Summer of Nix. It is 3 months during the summer when you do mob programming for some on-source projects using Nix. During this time, I learned a lot about Nix, and I would like to pass some of this knowledge to you. If you'd like to reach me out afterwards and ask some questions, feel free to do so. Here is my email, my matrix handle, or you can find me on GitHub. So what's the problem with the current development setup? Well, let's say that you have a Python project. You opted out for using something more advanced that requirements TXT, like Python poetry. So your dependencies are pinned, hashes are checked, everything is fine. But then a new teammate joins your team. He won't want to make the project run on their machine. So you clone it, start installing, and it fails. But how so? It was supposed to work. It works on your machine. Well, you start asking a simple question like, do you have the same version of Python? And then you maybe notice some errors. It can be, for example, from some compiler error. So you may need to install GCC. So install build essentials. Okay, then it complains about something else. It needs Python headers. So for that, you need to install Python 3-dev if you are on Ubuntu, or Python 3 Devel if you are on Fedora. It's different. It differs from distribution to distribution. Okay, another problem fixed. But now you get another package has an error. It tries to create bindings to some system library. So you need to install the library, and let's hope that your distribution has the library, and that the library has correct version, and that it will not break anything. So that's a lot of things we need to hope that goes right. Okay, now the project's built successfully. We have wheels for everything else. Well, unless you are, for example, running Alpine Linux, which uses musl instead of glibc, in which case there are little to none Python wheels pre-built. The worst thing about this is that you need to repeat it again and again. This process is not reproducible. When a new teammate joins your team, you need to do this dance one more time. When you want to build this, when you want to run a CI, you need to do this again. And you want to build a Docker image? Yes, you guessed it. you need to do it one more time. So, and all of this may result in that you are building a project, but actually you are running and testing a different one. So if only there was a better way. And as you may guess, I think there is. There is Nix. Nix is a package manager and a programming language. It enables you to create declarative builds and deployments. It has also a package registry with over 80,000 up-to-date packages. Here is a graph from Repology. On the x-axis, there are a number of packages in the repository, and on the y-axis, there is a number of fresh packages in the repository. So you strive to be the top right corner. As you can see, this is all Nix. One thing below is Arch user repository, and red dots are Debian repositories, blue dots are Fedora repositories. So I would like to show you how you can utilize the powers of Nix in Python with minimal knowledge. Therefore, I will use a project called Poetry to Nix. It reads PyProject Tomu and poetry log file to build your project using Nix. So, demo time. Here, I have, is it big enough for you? Okay. So here is an empty repository. I will use an official template to get the basics. It created an empty Python application and a minimal PyProject Tomu. It has no dependencies. So let's add Flask and build a simple web server. So we import Flask from Flask. Create an object. And create a simple handler for a GET request. That will return a simple message. Now we need to add, we also need to add the main function to run this. So main. Now we need to add it to scripts in PyProject.tomu. And we can try building it with Nix. By default, Nix tries to download all dependencies from the cache, and it doesn't succeed. It builds them from sources. So now we build the application, and the artifact is stored in a result directory, and we can try and run it. And we get a response. Notice that we didn't even need to touch the flag.nix file. And by this time, you have a Python project that is built using Nix, and new teammate can onboard your team and you can be sure that you are really running the same applications. But let's take a look at the flake.nix file. Flake.nix file needs to follow a schema. It's called the flake schema. It has a dictionary-like structure with a fixed set of attributes. First, we define inputs. These are dependencies for our flake. We will use Nix packages and poetry to Nix. Then there is output attributes. It is a function that returns a package set. Nix can build projects for many different systems. We use each default system to iterate over systems and create and build the application for all of them. By default, this will create application for Intel and ARM architectures on Linux and Darwin. And then now the most important for us is this packages attribute. It is a set that contains different targets. Here we create the target my app using make poetry application, and we make it the default target. Okay, now that we know what is in this file, we can try and edit it and add another target. Let's build a Docker image from our application. So I will add a Docker target. I will use Docker tools from Nix packages. And I will use function build image. The build image function takes several attributes. We need to name the Docker image. So let's call it app. It needs a tag. So 010. And create it. This will edit the timestamp. And config file, config. Config will have a single attribute, and that is command that we will use to run the app. We specify the path same as before from the command line. So bin app. Okay. And there is one thing I cannot forget is make this a recursive attribute set because we reused my app in this set. Okay, so this should be it. Now, if you want to build a different target, after the dot, you need to type a hash and then name of the target. So in this case, it's Docker. This will create a tarball containing the Docker image that we can then load from to the Docker or Podman. So I will use Podman. We can take a look at the image. And it's here, we created it just now. Let's try to run it. And verify that it indeed sends us a response. Okay, it does. And now we can be sure that the application in the Docker is the same that we run as on the localhost. But there is also another advantage. The application, the Docker image contains only stuff necessary for building the image, nothing else. This is important because every extra package in the Docker file is an additional attack surface. At work, we use container scanning to find vulnerabilities in our images. And one day we found out that one of our images was vulnerable. And we explored it and found out that the issue was not with our application, but with another tool that came from the base image of the image we run. So if we used Nix for building this image, this problem wouldn't occur. OK, so I promised also a better shells. Because you don't want to run Nix build every time you edit a file. This is not the development cycle we are used to as Pythonistas. So let me introduce you to dev shells. Let's take a look at the flag.nix. At the bottom, there is a dev shell. This creates us a new shell environment. We can specify additional packages that we want to be accessible in our shells. And so let's do so. I will add RAF, the formatter, and let's add also kubectl. The make shell function has a fixed set of attributes that it takes, and every one which it doesn't know is considered an environment variable. So, and this variable will be exported in the shell. So let's add some environment variables. Now, to activate the shell, we will run nix develop. And now I have the RAF program and also the kubectl. And we can echo the environment variables. And now I can also edit the Python sources interactively. So let's run Flask in the debug mode. We still get the hello PyCon response. So let's now change that. The server automatically restarted, and we can check that we indeed get a different response. This can be even nicer with an additional tool. The tool is called derenv. Derenv activates can activate the nix shell when you enter the directory and deactivate it when you leave it. So let's first, I will show you that I have the kubectl, and when I out of the deactivate the shell, I should not have it. Or here it is. OK, so to activate the derenv, I will just echo use flake to env-rc. And I have the kubectl. And now, when I leave the directory, I don't have the kubectl. So the derenv is not in any way related to Nix, but it integrates really nicely with Nix. So now we can set up the CI. But first, let's add some tests so that we have something to run in CI. We will add PyTest to dev group. and write a simple test. We will request the index URL, and we will do a GET request, and we will assert that PyCon is in the response. Now we can run the PyTest, and it fails because it's not a string, it expects bytes. Oh, okay, so we have some test-driven development here. So PyCon is no longer there because I edited it, so let's test for Nix. Okay, so for the CIs, I will not type them by hand, but I have it there here. So I will just copy them. For CIs, it's really simple because all you need to do is to pull from some image that contains Nix, and then you can run Nix develop with the specified command. So this is the GitHub action. And there is also one for GitLab. It's a bit simpler. Okay. Okay, and now we can push it. I will just add everything and push it. So this action will run, and in the meantime, I would like to thank you. And I hope that this talk made you curious about Nix, because I think that while Docker was able to solve the problem, it works on my machine, I think that Nix was able to improve it and solve it everywhere, on local development, CI, and in deployment. Now we just scratch the surface on the Nix, because Nix is a language-independent tool and can create declarative builds and deployments for any language, not just Python. If you would like to see the repository, it's at this GitHub URL. Here's my contact if you would like to ask me any additional questions. And if you would like to learn something more about Nix, here are some websites that I think contain a pretty good material for that. Thank you.
Thank you, Matúš. We have quite a few questions. So let's start with the one with the most upvotes. It's kind of related to what you ended with. And that is that some folks prefer to use Docker or Podman for their development containers. You prefer Nix. What is it that Nix gives you that Docker or Podman doesn't? Why do you prefer it?
Well, it depends, because if you are if you want to build Docker images with Docker instead of Nix, yeah, sure you can, but there are the disadvantages I talked about before, that you are not sure that you are really running the application that you are developing. Maybe you are not using the same base image, or also, like some of it is that Docker images are, I think that they are really difficult to get right, and they can, as a result, they can be insecure and also not reproducible, because when you want to install something in a Docker image, or at least we did it, we run apt update and apt upgrade to get the newest packages. But this may break the build because you don't know what's updated. And with Nix, everything is pinned and hashed, so you are sure that it will build always the same as before.
Okay, so that's when we have those hashes, and this file, you are guaranteed that you get a specific file. Okay, so absolute reproducibility would be what gives it. Okay. Is there an easy integration into more robust IDs such as PyCharm?
I'm not sure about PyCharm. I don't use it, but there are some language servers. So if PyCharm supports a language server, I think you should be able to get it done. There is one I think for Vim and Emacs and also VS Code. So that's it.
So most of the popular editors are supported. There's another one. I kind of missed what's actually in your build container image. Does it build on Nix OS as the underlying platform or something else?
No, it's built from scratch. There is no base image. That's the advantage, that it will contain just the stuff that is needed for building the application, nothing else.
Yeah, one of the things, by the way, which I really enjoyed personally about Nix when I was playing with it, is that it works with pretty much any Linux distribution. Yes. So you can, if you're using Ubuntu, Fedora, whatever, you can just start using that. So that was I enjoyed it a lot.
That's cool, because as I said in the introduction, for example, you need to install the Python headers, but they are called different name on a pretty much every distribution. So this is a bit easier, at least for me.
One thing that scared me off, by the way, was that the language seemed, someone said that it's like a cross between Haskell and C++.
It doesn't. It's not from the C language family. I think it's more from the ML language family. So it's not so familiar, but it's in terms of syntax, it's a simple language. It doesn't have that many features. So I think like everyone is able to learn it pretty quickly. The another thing is learning about its ecosystem. That's a bit more challenging. But the language itself, I think it's pretty simple. Once you understand it. Firstly, I didn't understand the word. I was like, where should I put the semicolon? Should I put it there? What is this thing? But then it just clicked for me and it worked. If you find me around, I can do nice translation between Nix and Python. So maybe that will help you.
That sounds very cool. So absolutely, let's use the opportunity. There's another question. How well does Nix manage path dependencies, path deps? If I, for example, have a project that depends on my other project, and I use path dep in my pyproject.toml, subsequently, search results also suggest that Nix appears to have issues with development dependencies here and there. How likely is that a development path dependency will cause complications?
I'm not sure.
So if you're depending on other packages, as far as I understand.
The file system?
I don't know who asked this, but I think this is mostly about managing dependencies. So if you're depending on another Python project somewhere.
Like if it's in your poetry, if you declare it by poetry, it's non-issue. And if it's where you can create like derivation for that project and then import it in your projects as well. So I think it's possible, but it will not be this straightforward.
Okay. Do you have to use poetry?
No, you don't. I just wanted to use it because I think it's the most straightforward, and you don't need to have the Nix knowledge. there are other tools, or you can in Nix repository, there are also many Python packages. So you can use packages directly from Nix repository. But the one disadvantage that I think is about this approach is that there are mostly packages on the latest version. So if you want an older one, you are pretty much out of luck. So I like this because you can have any version, and the poetry will load the correct version for you.
And if you do like poetry to Nix, it generates some sort of derivation or something else? What does it do?
I think it reads through the log file and downloads it according to the hashes. It must also it generates the derivation. Maybe I can show you. I will need to build the app. And these are the derivation that it depends on. So for example, the first is the hash, but then here are the derivations. Here you can see Flask depends on markup safe, Werkzeug is dangerous, and so on. So this derivation, the Python poetry to Nix created for you.
That hash looks like it really is dangerous with that file name. Yeah. Another question: why are you using Fedora instead of NixOS?
Because of this talk, I migrated to NixOS on a different PC, but I didn't want to break. I didn't want to risk it that something happens. I want to have my old environment. But after this talk, I'm pretty much on NixOS.
Nix prides itself on complete reproducibility, but how do I specify that I want security and bug fix updates of the underlying platform? I'm rarely interested in the exact version of glibc, OpenSSL, GDBM, glib, or gettext, but I want them up to date with a major ABI compatible version.
Okay, so there's multiple ways how to do this. If you use, for example, poetry, and you want to have your dependencies up to date, there are projects like Renovate or Dependabot that will build, that will search for dependency and create the merge request for you. And then if your test run, and it can merge it automatically. So this is how you can have your Python dependencies up to date. And there is also a way how to have the Nix dependencies up to date. Because if I want to update the Nix dependencies, I run a Nix flake update, and it will update them. There is also integration for that it will do periodically and merge it if it runs tests successfully.
So did I catch correctly that it runs tests and makes sure that it keeps working after you update those?
It's up to you. I would like to run the test. Like it's not the feature of Nix. It's just the integration in the CI. It will bump the version, and in the CI your test will run, your build will run, and if it's successful, it merges.
This is why I want to write tests, folks. Okay. What kind of situations or projects you see Nix as not being the best choice, and why?
Probably some project that have Python that has dependency management really well done. For example, some Rust projects, because in Rust ecosystem, the main and probably only package manager to use is cargo. Everything built with cargo, and you create a static binary, or you could create the binary for it. So in Python, it's a bit different because there is like no canonical way to build your build an application. You can have poetry, there is Hedge, setup.py, and many others. And also, since you don't have the binary, it's a bit more difficult to distribute.
And what have you not been able to achieve using Nix, or where is Nix difficult to use for what kind of projects?
I mean, for me, the most Nix is I see it as a young language, or it's a young project, but actually it's not that young. It's around 2000 or so. But I think the most difficult part for me is debugging, because it's a pure language and pure functional language. So there isn't something like, okay, I will give their print statement. So that was difficult for me. And also, as you said, that some can say that Nix is like a marriage between C++ and Haskell. It pretty much inherited the error messages from C++. So that's something that I would like to see improved.
Got it. And our final question, what feature do you miss the most in Nix?
I'm not sure because I haven't used Nix. I learned Nix just last summer, so I haven't explored it into depth. But probably that you always need to be on the latest stuff. It's good to be on the latest stuff, but sometimes you need to have an older dependency because some other projects that you don't control relies on it. So maybe this one.
Thank you so much. Let's give a big hand to Matúš.
Thank you.